That is big O asymptotic notation. Thank you.
Good morning everyone. I am Sinjana. I am here to explain big omega notation of asymptotic notation. Big omega notation. Omega of g of n is a set of all the function with a greater or same order of growth as g of n. Its definition is a function f of n is said to be a omega of g of n, then it must be a function f of n belongs to the omega of g of n. There exists a positive constant, that is c, and n naught. The condition for big omega notation is a function f of n must always be greater than or equal to c into g of n. As you know, c is a constant. So the graphical representation of omega notation is like this. Here the vertical axis represents the time and horizontal axis represents time. N is our input value. And f of n is a function. G of n is some simple function which compared with this. This graph representation f of n is equal to omega of g of n, that is, as you know, f of n must always be greater than c into g of n. This represents the lower bound execution of algorithm. This is for least time to do a work. Let represent these in terms of g of n. F of n is always greater than c into g of n, and this is as you know. F of n is equal to 2n squared plus n. Just consider this as an example. G of n means n squared. If c is equal to 2, then 2n squared plus n greater than or equal to 2n squared. For example, if the n value is 5, then by substituting this n value to this equation, we get 2 into 25 plus 5 greater than or equal to 2 into 25, which means 55 is greater than or equal to 50. This shows that a function f of n must be greater than or equal to 50. If you consider the n value has a 0, then n must be greater than or equal to 0. Thank you.
Hello everyone, I am Sport Edition. I am from JNSC Shimoga 4C CSC. Today I am discussing about asymptotic notation. My part is theta notation. Theta notation provides a tight bond between an algorithm unit. It represents both upper bound and lower bound, meaning that algorithm runs in an predictable range. In other words, algorithm represents f of n is equal to theta g of n. Has its growth rates and the division into two functions. This is a graphical representation of theta notation. Here an example. Compare order of growth of 1 by 2n and n minus 1 and n squared. To express theta notation, we focus on higher